Welcome to the final exam review. We're starting on number 29. If you need the other videos, please see the Schoology assignment that has the other videos on it. Number 29, the log base 4 of x equals 5. It's hard to solve a log problem when it has log in it, so we rewrite it in exponential form. So we take base 4, we swirl around to the 5, and then to the x. And what that really tells me is you take your itty-bitty base, you raise it to the 5th power, and it equals x. So you put 4 to the 5th power in your calculator, and you come up with 1,024. So x equals 1,024. All I did was rewrite this in exponential form. The little number, the base, raised to the power, which is on the other side of the equal sign, has to equal what we're taking the log of, which is x. Number 30, solve 5 to the x power equals 45. When x is in your exponent, the easiest way to solve this is to take the log of each side. So I'm going to take the log of 5 to the x power equals the log of 45. Remember, when you take the log of something and it's raised to a power, the power can be moved out front. So now I have x times log of 5 equals the log of 45. In order to get x alone, I divide by the log of 5. And when you're doing this in your calculator, you have to remember to use parentheses after the 45, because remember, it opens it for you. And when you put that in your calculator, you come up with 2.37. So the answer to number 30 is 2.37. Number 31 is very similar to what we just did. X again is in the exponent. So I'm going to take the log of each side. So the log of 3 to the x minus 8 power equals 48. That allows me to take this whole piece, x minus 8, and move it in front. Because I want to keep it as a whole piece, I remember to put it in parentheses. X minus 8 times the log of 3 equals 48. I'm not going to distribute this. You can. It wouldn't be wrong. It just makes it more work. I'm going to go ahead and undo that division by dividing each side by the log of 3. Okay, and when you put that in your calculator, 48 divided by the log of 3, you come up with, well, on the left I still have x minus 8, the log 3's cancel, and I'm left with 100.60. And then when I add 8 to each side, negative 8 plus 8 goes away, you get x equals 108.60. That is the answer for 31. Now, I am going to erase this, so you may want to pause the video if you need to write this down. Okay, number 32 says expand the natural log of x to the 5th over y squared. Now remember, log and natural log have the same powers, and expand means to make it longer, okay, or bigger. So when I have the log or natural log of two numbers being divided, I can rewrite it as the log of 2 that are being subtracted. So the log of x to the 5th minus the log of y squared. And remember, the exponents have to come out front. So what you're left with is 5 log x minus 2 log y. If you need to write this down, please pause the video as I am moving on to the next page. 33. What will be the value of an account where $10,000 is invested at an annual rate of 3.4% compounded continuously? You have to read very carefully. If left untouched for 20 years. It tells me compounded continuously, I have to use the formula A equals P times E to the RT. Okay? A is your end amount, P is your principal or your starting amount. So my principal is going to be $10,000 because that's what I start with. Okay, so I end up with A equals $10,000. E is a number, right? So times E times E. My rate, it says 3.4, but remember I have to move the decimal point 2 to the left. So when I do that, I actually get 0.034. So E to the 0.034 power times time. And your time has to be in years, which it is. So my time is 20 years. And I'm going to go ahead and type all of that into my calculator. 10,000 times E raised to the 0.034 times 20 power. And you come up with $8,978,472.92. That's how you do 33. 34 says, how long would it take a $500 account to become worth $2,000 if it were compounded continuously at 3.8% annual interest? Similar, but let's look at what we have. 3.8% tells me my rate is going to be, now remember I have to move it 2 to the left, so 0.038. Okay, what's the amount that I started with? I started with $500. It says, how long would it take $500? So my principal is $500. Now notice you're missing your time here, but they give me this other number, 2,000. Okay, that's how much they want you to have at the end. So that's going to be your A amount. So I'm going to plug these into the same formula we have right here. So A is 2,000 equals P, which is 500, times E times E. I know that looks, there you go, sorry. It should be times. It doesn't like when I do little dots. Well, we'll just leave it and we know that's times. Times E to the R, which is point, here we go again, .038, and I don't know T, so I leave it as T. Now, this is very similar to solving equations like we did in the last video, okay? Because in the last video, or last page even, it wasn't even a video, in the last video, we solved when the variable was in the exponent. And I took the log of each side, or the natural log. I can't do that yet because I have this 500 attached to E, which is being raised to the power. So I have to divide each side by 500 first. And I get 4 equals E to the point, it doesn't like when I draw little circles. Let's try one more time. Okay, well, 0.038T. Now that I have the base being raised to a power alone, I'm going to take the log or natural log of each side. And because I have E, I'm actually going to go ahead and take the natural log of each side. So I have the natural log of 4 equals the natural log of E to the 0.038T. Remember, when you take the log or natural log of something and it's raised to a power, that whole thing comes out front. So now I have the natural log of 4 equals 0.038T times the natural log of E. Whether you remember this or need to put it in your calculator, the natural log of E is simply 1. The natural log of E is always 1. So I'm left with the natural log of 4 equals 0.038T. To get T alone, they're being multiplied. I undo it by dividing each side by 0.038. And when I put that in my calculator, the natural log of 4 divided by 0.038, I get 36.48. 36.48 equals T. Let me write that up here. I am going to erase this so I can go on to the next problem, so if you need to pause the video, please do so. Okay, so here we go, and bring back that problem I covered up here for us. Okay, so 35 says the population P of a certain city can be modeled by the equation P equals 140,350 e to the 0.013 t, where t represents the year 1990. According to this model, in what year will the population be 285,000? You don't even have to write the equation here. They give it to you. All I have to do is plug in my information. They want me to plug in this, and this is my ending population, or my p-value. So very similar to the problem we just did. So I have 285,000 equals, and now I'm just using the formula they gave me. Okay, so it equals 140,350 e to the point, or 0.013 t. Just like before, I can't take the log or natural log of each side till I get the number that's being multiplied away from e. It's being multiplied, so I'm going to divide it. Okay, so in my calculator I'm putting 285,000 divided by 140,350. You come up with 2.031 equals, these cancel, e to the 0.013 t power. Now that the base is alone, I simply take the natural log of each side. Again, the natural log because I have an e. So the natural log of 2.031 equals the natural log of e to the 0.013 t power. And again, that allows me to bring this out front. So I have the natural log of 2.031 equals 0.013 t times the natural log of e. Just like before, the natural log of e is 1, so that just goes away because it's being multiplied. And I simply divide by 0.013. And when I put this in my calculator, so I'm putting in the natural log of 2.031, and I'm dividing it by 0.013, I come up with 54.50. Okay, but that's not quite my answer because it says in what year. So if I started when t was 0 in 1990, I'm going to do this over here in, I'll do it in red so you can see it. Nope, not red. I'll do blue. If I started in 1990 and I have to add 54.50 years on, that happens in the year 2044.5. So what year does it actually happen in? 2044 would be your answer.